The next question, which of the following are not the units of self-inductance? Before telling about self-inductance, or before telling about the question, we need to discuss what is self-inductance. See, I got a coil, one coil. If there is any electricity or magnetic power is given to this coil, there is a flux created, a magnetic moment created. They term it as inductance. I got two coils. Current or magnetic effect is given to one coil. The same electrical current is given another coil. Because of a flux created between these two coils, there is a mutual inductance happening. If two coils are there, it's mutual inductance. One coil is there, it's self-inductance. So I got an option, which of the following are not the units of self-inductance? So four options are given: Weber per ampere, ohm second, joule ampere power minus 2 per ampere square. So considering I don't know the answer for this particular question, so there are a lot of questions you won't get an answer, you don't have the explanation. In that case, from the answer you are able to identify what could be the answer. Sometimes. Okay, this is the tips, you can note it down. See, you are able to see it here. Weber per ampere, ohm second, joule ampere power minus 2. Obviously we can think, okay, so three things are common. Obviously ampere. Obviously there should be one which can't be an answer. So this is not an answer because ampere is common here. Obviously they have played between this ampere. Apart from this, over here this is divided by, and this is also divided by, because it's ampere power minus 2, it's divided by. So my guess is like this can't be an answer, and my guess is this can't be an answer, this is an answer. So this is not a unit of self-inductance. From the answer itself you are able to identify what could be the answer. Now let's move on to the explanation. Over here, magnetic field L is equal to psi or pi divided by I. So the unit of inductance is Weber per ampere. So the first one is the unit. And over here, epsilon equal to L of di divided by dt. So I am trying to traverse it, di by dt here, epsilon into dt divided by di. So obviously epsilon into dt is second, so this is also an unit, it can be. And apart from that, epsilon into dt by di, which indicates it's a joule per ampere square, it's di ampere square. Obviously this can't be an answer, so this is the right answer. The option is C. This is not the unit of self-inductance. Let's move on to the dimensional formula of magnetic flux. Obviously, I got a metal or some object, a motor or something, which is placed, a coil can be, which is placed between the magnets. A flux is created which started used to rotate it. You are able to see some rotation. So this is a principle they used in generators. So I'm talking about the dimensional formula of magnetic flux. Over here, F is equal to Q into V into B sin theta, nu into sin theta, it's nu. So obviously I took this B, put it here, F divided by Q into nu into sin theta. So obviously this one. So I remove these things because I don't want a numerical value sin theta and all. Over here I got force M into L into T power minus 2 and nu into V. Q into V, that's LT power minus 1 into A power T. It's nothing but A power minus 1. So obviously cancelling it, you are able to get it's A power minus 1 LL T. Over here you got T power minus 1. It's T power minus 1. t power minus 1. L is so m L, so a power minus, so over here minus 1, it's my a power minus 1. The answer is m t power some m. Okay, so it's t power minus 2, it's minus 1. Yes, t power minus 1 m L t power minus 1, it's not t power minus 2, it's t power minus 1, a power minus 1. You got this one. And obviously we have to analyze it over here. Magnetic flux is equal to B into area. So I need to calculate the magnetic induction B, and from there you need to calculate the area. So B, I got the B here, it's minus 1, t power minus 1. And you got the L square here. We got the final formulas m L square t power minus 1 a power minus 1. So the answer is A, it's not B. The answer is A. Now, a wire, so I'm going to talk about the error percentages and other stuffs. A wire has length of 6 plus or minus 0.06 centimeter, and you got the radius of 0.5 plus or minus 0.05, and you got the mass. What is the maximum percentage of error in the density? This is the question. Obviously, density is equal to mass divided by volume. Since it's a wire, obviously it's a wire. It's a wire. Obviously, the volume of the cylinder is a pi r square into L. So we got density is equal to m divided by pi r square into L. So taking the differentiation, we are able to get delta P divided by delta rho divided by rho is equal to delta M divided by M plus, since we got R square here, 2 into delta R divided by R plus delta L divided by L. So we have to give delta M. Delta M is 0.003 divided by 0.3 plus 2 into delta R over here. So this is the one, and over here, and here is the one, over here, and here is the one, and over here. So solving this equation, you are able to get the answers are, so it's 0.01 plus 0.02 plus point. So the change in density, the error in density is almost 0.04. I need to calculate the percentage, maximum percentage of error. This is the formula, percentage of error equal to relative error into 100. So related to other stuffs, this error happens, so relative error. So 0.04 into 100, so we got a percentage of errors 4. The answer is 4. The option is A. This is real different question. The displacement of particle moving along x-axis with respect to time is x equal to at plus bt square minus ct cube. What is the dimension of c? What is the dimension? So what we have to do is like, so this is how, if you're receiving this kind of question, this is how you need to manipulate. What you have to do is like, you have to manipulate with 1 and 1. So this is how you need to manipulate. This one, just take the left hand side is equal to an object from the right hand side, RHS. So x equal to ct cube, x equal to, so ct cube, x equal to bt square, x equal to at. This is how you should take it. Wherever the problem comes like this, you should take like this. So the question is dimension of C. Dimension of C. So we don't want these things. So x is equal to ct cube. Discard these things, plus or minus. I don't want this one. because I need to find the dimension enough. Okay, so obviously C is equal to x divided by t cube. This indicates, since it's a movement, so that is a length. I should have length divided by t cube. So L t power minus 3, obviously C is the answer. This is how you need to calculate, considering that if they're asking dimension of B, it's L t power minus 2, dimension of A, L t power minus 1. This is how you need to solve it. Okay, so the length and breadth of a metal sheet are, the length is 3.124 and the breadth is to 3.002 respectively. The area of the sheet up to 4 correct significant figure. What you will do? Immediately you will try to multiply like this. Length into breadth, area is equal to, do not do it. The answers are 1, 2, 3, 4. They are asking 4 significant figure. Over here 1, 2, 3, 4, 5. No. 1, 2, 3, 4, 5, 6. No. 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 1, 2, 3. No. 1, 2, 3, 4. Calculate it. That's it. For lot, so in NEET exams, what you have to do is like they will have the answers. You can easily manipulate from the answer itself. Don't do this calculation, waste your time. This is a simple tip in NEET exam.